Let's have a look into C programming language. And, by the end of this session, you will be able to understand the importance of learning the C programming language. Know the basic structure of C programming. Identify the importance of downloading the Integrated Development Environment (IDE), such as Dev C++, before writing the program. Learn the significance of each step involved in writing a C programming language. Importantly, develop a C programming code with understanding. Now, let's see the importance of learning the C programming language. Among the various programming languages, C remains the most popular one globally. Learning C helps the learner gain basic knowledge about programming languages, making one quickly learn other programming languages like Python, C++, C#, Java, etc. To learn C, one need not have prior experience with any other programming language. With such importance associated with the C programming language, let's see the basic structure of the C programming language. However, before following any programming procedure in the C language, one must download the Dev C++, an IDE which helps in two ways. 1. It helps check the program's correctness in terms of semantics and syntax and ensures the compilation of the correct code. Here, semantics refers to the meaning of the program, while syntax is like grammar. So, in other words, Dev C++ helps the programmer to check whether the given program is correct in terms of meaning and grammar. Secondly, the Dev C++ compiler embeds specific files, which helps run certain functions without writing the code. For instance, the Dev C++ contains the stdio.h header files with the inclusion of some critical files, such as the printf and scanf functions. So, the programmer can call and execute the print function without writing the code by downloading the Dev C++. Now, let's see how to write a C programming language. To understand better, one can divide the C program into various levels, which include 1. Problem description. 2. Preprocessor. 3. Definition. 4. Global declaration. 5. Main function. 6. Function definition. The first step includes the problem description or giving a name to the program, and here, we explain the purpose of writing the program by providing the title of the program. Example. In this program, the descriptive part is titled, Addition of two numbers. In this second session, the preprocessor section, we write #include stdio.h header files. This is known as a preprocessor directive. Because below this line, we write the main function, which denotes the program's start or will start executing from the processor. Before the program enters the processor, the programmer gives some instructions. Therefore, it is known as a preprocessor directive. It is an instruction to include stdio.h header files that contain various functions from already existing files. To access those functions, such as printf, the insertion of header files is done before the compilation begins. As a result, during the program execution, functions embedded inside these header files, such as printf and scanf functions, are directly inherited into the program without writing the code. These stdio.h are located inside Dev C++, the C programming language compiler. So, if the programmer does not call the stdio.h header file during program execution, there will be an error while calling the printf function. In addition to printf and scanf, some other functions are also embedded inside these files, such as square root, sine, cos, and many more. So, including stdio.h header files plays a significant role in programming. Whenever a code starts with the hash symbol, it is a preprocessor directive. And the preprocessor statements and main function do not end with a semicolon, whereas all the other statements in the C programming language end with a semicolon. Next, third, definition. It is an optional section. One can create any constant in the definition section and inherit its value into the program. For example, if the programmer wants to use the constant pi, for which 3.14 is its value, it can be included here. In addition, The define section allows one to use constants inside the code while replacing the constant with its value. We use the hashtag define in C programming language to create the constants. Where hash in C language denotes the symbol for the preprocessor directive. By including hashtag define, we can use constants within the code. For example, hashtag define pi 3.14. In this example, the constant pi is created with an associated value of 3.14. So, while writing the program, 3.14 replaces the constant pi wherever we use it inside the code. Hashtag define helps the source code to compile and modify easily, enabling it to be used across various execution environments. For the preprocessor and definition section, we do not use a semicolon. 4. Global declaration. Global variables can be declared before the main function. In the global declaration section, the programmer can include all the variables used in the program. By declaring the variables in this section, those variables are made accessible across every program function. For example, the format for global declaration, as shown in this program, is int add, with int x and int y arguments being included inside the parentheses. Here, int is the return type, add is the function name, while int x and int y are arguments. For global declaration, we use a semicolon. Next step includes the main method. The main method is the standard from where the program starts executing, irrespective of any programming language like C, Java, .NET, or any other language. As a result, main is a function that will appear in the C programming language every time, and from here, the program starts to execute. The main method also helps allocate space in the memory, which is helpful during program execution. The defining of int main can be done only once. If given twice, there will be errors. While defining the main function, the format should include the type of data returned by the method and the function's name. It is followed by parentheses and curly brackets. In a nutshell, the main function prototype includes return type, function name or method name, argument list, and the body. Importantly, these curly brackets are to be included compulsorily within the program as they indicate the start and end of the programming function. Whatever code the user provides inside the curly brackets, it will get executed. Inside the curly brackets, the programmer can include statements or code. All the statements in the C programming language end with a semicolon. After ending all the statements, we write return 0, followed by the closing of curly brackets. Let's see a typical example of the main function. First, we declare variables by prefixing the data type. Where int is a data type, and a, b, and c are variable declarations. There are different data types. We will discuss them in the next session. Next, we write printf function to display statements such as enter the values. The definition of printf is already done inside the header files. As a result, printf is being inherited into the program from the header files. Next, scanf function helps to get the values of the user. Then, we write the calling function or member functions. These are instructions given by the user. As a universal standard, to add a group of instructions. Here, add is the function. Functions are meant to implement the logic for the data declared. Here, again we write printf function to display the sum of the given numbers or the final output. Finally, we write return 0. If we use int as the data type. Importantly, the main function consists of either void or main as a return type, but not necessarily int alone. There are different ways to express the main method. Some basic types are void main and int main. While void main does not necessitate returning a value, int main guides the function to return the value in integer form. Hence, during int declaration, it is mandatory to include return 0. Let's see an example for void main. Here, the output would be like, there are 12 pupils in a class. Now coming to the int main function example. Here, we declared current as the variable while assigning a value of 2023. Next, we write the printf function, and return 0. Here, we need to compulsorily include return 0, as it is an int data type. Int main instructs the function to return a value in integer form. As a result, the programmer should include the return 0 statement at the last line within the int main function. Though the return 0 denotes the ending of the main function, closing the curly bracket or flower bracket will actually make the ending of the main function. As an extra note, for few seconds, we will discuss the printf function in C. We have seen that we can print text using the printf function. Though in other languages such as C++, Java, and Python, we use the printf function to display the variable's value. In C language, the printf does not work as it is. For example, if we type int x equals 5, printf x at the output, nothing will be displayed. Instead, along with the printf function, one must use the format specifier in C language. A format specifier includes a percentage sign that is embedded inside the double quotes and a comma suffixed with a character. For the int variable, we use %i or %d within the double quotes in the printf function to display the value in the output. Similarly, we use %f for float and %c for char. Such as int x equals 5. Printf %d x. Here, one can see 5 as the output at the display. The syntax for scanf is similar to that of the printf function. Notably, while calling the values from memory, we use the format specifier and comma in the C programming language. Otherwise, we can use printf without a format specifier to print statements like shown here. For example, we didn't declare the variables in the void main. Hence did not include percentile along with the printf function. Otherwise, in the int main example, the printf function includes %d as it is used to showcase the output. Here, the variable declaration is made, requiring the function to fetch variables from memory. In the same way, in the main program, while here the %d is not used, in the later part, we have used the %d as it requires fetching variables from memory. And the next part of the program includes the user-defined function. A typical structure of a user-defined function is as follows. This is called function definition or called function. Here, add, int x, int y, is the function name. It means the functions return a value, which is an integer, and, inside the function body, it defines the function and what it must do. In this program, we have included the return statement x plus y, within the curly brackets. Finally, after the return statement, one should close the curly brackets. Here will some good-to-know points. While in the function definition, we don't use a semicolon, in the function declaration, we use a semicolon. In the function definition section, we give the opening and closing of flower brackets instead of a semicolon. Statements that are represented within the double forward slashes are considered comments. Such statements are used for descriptive purposes but are not considered part of the code. Writing a comment during the program execution is optional. Till now, we have seen the structure of the C program. In the next session, we will look at the steps involved in executing a program.